Hello everyone. Today we are going to see about rational numbers of class 8 mathematics. In the rational numbers, we are going to see the definition, properties of rational numbers, their operations on rational numbers and their simplification applications in exercise problems. See, in numbers, we have seen numbers every day. We are seeing numbers every day, like first day of the week, 5 seater car, 1 liter milk, 1 full ticket, etc. So these are all the numbers we used to come across every day in our life. But you see, when I say half liter milk or 1/4 of any work or half liter oil, whatever it is, there we are using different types of numbers. You just see the next slide. In that we see half liter, 3/4 of a liter, or half ticket in bus travel, 3/4 pant. These things we are using these numbers which are different from integers. What we have seen already, whole numbers, integers, natural numbers and all we have seen already. These are the new set of numbers. This new set of numbers are having one numerator and denominator. This form is known as rational numbers. So next slide. When you see the rational number, this can be written in the form of p by q, where p and q are integers and the denominator q is not equal to 0. That is very important here. Now see, 2 by 3 minus 6 by 7 are all rational numbers. And now the special thing is here, 0, minus 2, 4, all integers. All the other integers also can be written in the form of 0 by 1, minus 2 by 1, 4 by 1, etc. Hence, every integer is a rational number because every integer can be written in the form of p by q. Next. Then, when you see the rational numbers, what are the applications of the rational numbers in daily life? We are seeing so many ways. See, assignment half portion, commercial we can see 90% it will cure. So these doctors are preferring this like toothpaste advertisement. We have seen this. Marks awarded is also in rational form. Like this we can use rational numbers. We are using rational numbers in many ways. Now solving the equation also, we just say x plus 2 equal to 13 where 11 is the solution for this, which is an integer or natural number. X plus 5 is equal to 5 where x is 0 is an integer. 2x equal to 3, there comes the solution as a rational number. Yes. Now how to represent this rational number on number line? See, 3 by 4 on number line. How to use this? You know the number line. Number line consists of all positive numbers, 0, negative integers. Now all together, when you take a number line and how to represent 3 by 4 on number line. What we have to do? You should take 3 by 4 as a proper fraction which is less than 1. You have studied about fractions in your lower classes. 3 by 4 is a proper fraction. So numerator is less, denominator is more. This is definitely less than 1. So you take a number line 0 to 1. Divide 0 to 1 into 4 equal parts because the given rational number contains 4 in the denominator. So divide it into 4 equal parts and first part is 1 by 4, second part is 2 by 4 and 3 by 4. We are marking like this. This is the way to represent a rational number on number line. Now we see the properties of rational numbers. These properties commutative, associative, distributive, closure, all these properties we have seen for integers already. Same thing is applicable for the rational numbers also. What is commutative property? Even if you take any two rational numbers and you change the order of the rational numbers, when you add both or multiply both, the answer will be the same. See, for example, this is for numbers, any integer, 2 plus 3 is 3 plus 2. The answer will be the same. So, general form is a plus b is equal to b plus a, commutative property. This is under addition. Now, we are going to see multiplication. 4 into 5 is equal to 5 into 4. This is for integers. Same thing is for rational numbers also. Example, half plus 3 by 4, we are getting 5 by 4. 3 by 4 plus half, the same 5 by 4. So, commutative under addition we have seen. Same way we can see for multiplication also. Next is associative property. Associative property, you are taking three rational numbers here like A, B, C. Where A is a rational number, you can write it in the form of P by Q, B as X by Y, C as M by N, anything. So all the three are rational numbers. When you add first with second, get the result add with the third one, then you see the result. Now come to the other part. You add second and third, add the answer with the first one, you will get the result. Both will be the same. See for example, 5 is a rational number, means 5 by 1. 6 is a rational number, minus 6 by 1. You add both, getting answer minus 1, add it with the third number, 2 by 3, getting the result as minus 1 by 3. When you come for the other way, you combine minus 6 and 2 by 3, the result is minus 16 by 3, which is added with 5, we are getting the same minus 1 by 3. So this is called associative property of rational. Now comes the distributive property. Distributive property of multiplication over addition we are going to discuss now. Now 1 by 3 is a rational, it is multiplied by 2 by 5 plus 1 by 5. That is addition of two rational multiplication. This is now equal to 1 by 3 into, when you combine 2 by 5 and 1 by 5 we are getting 3 by 5. When you multiply you are getting 1 by 5 is the answer. Now come to the second part. Now 1 by 3. Go. Now 1 by 3 is distributed to 2 by 5 and 1 by 5. We just see 1 by 3 into 2 by 5 plus sign 1 by 3 into 1 by 5. What is the answer? 2 by 5, 2 by 15 plus 1 by 15. When you add both you are getting 3 by 15, which is again 1 by 5. So first answer and second answer both are same. So this is called distributive property. First one is adding both the number, multiplying by 1 by 3, or distributing 1 by 3 to both numbers which are inside the bracket. So we are getting the same answer. Therefore multiplication is distributive over addition for rational numbers. When you come for subtraction, the same result is followed. Even it is multiplication is distributive over subtraction, we can see the same example given here. Next is closure property. Closure property of whole numbers, integers and all you have seen in 6th and 7th. Now we are going to see the closure property of rational numbers. When you add any two rational numbers, the result is always a rational number which is closed under addition. Next is, example is given here, you can see very well. Next one is the difference of any two rational numbers is always a rational number. See, when you subtract 5 by 9 and 2 by 9, you are getting 3 by 9, which is again a rational number. Even the order changed also, you will get the same, some other rational number which can be closed, which is also closed under the subtraction, closed under subtraction. So this is this. Go. Now rational numbers are closed under multiplication also. You can get so many examples. If you multiply any two rational numbers, the answer will be a rational number. Division of rational number is not closed because all integers are not divisible by 0. So the denominator should not be 0. It is not defined. So we are not getting the answer in rational number. So it is not closed under division. It is not closed under division. Okay. Next is the additive inverse. What is the meaning of additive inverse? Additive inverse of a number is its mirror image in the number line. See for example 5. Its mirror image is minus 5 and vice versa. Minus 5 mirror image is plus 5. If a number is positive, its additive inverse is negative, and if it is negative, its additive inverse is positive. Additive inverse can also be defined as what you add to a number to get 0, that number is called its additive inverse. See for example 5, you added with minus 5, we are getting 0. Or minus 5 added with 5, we are getting 0. So 5 is the additive inverse of minus 5 and minus 5 is the additive inverse of 5. So for any rational number, the additive inverse is the negative of the given rational number. For example, you can take minus 3 by 11, the additive inverse will be minus of minus 3, negative of that number, minus of minus 3 by 11, which is equal to 3 by 11. Next is the additive identity. What do you mean by additive identity? If you add 0 with any rational number, we will get the same number. So this 0 is called the additive identity. Multiplicative identity of a rational number is 1 because if you multiply any rational number with 1, we will get the same number as answer. So 1 is the multiplicative identity of the rational number. Next called multiplicative inverse. What do you mean by multiplicative inverse? A rational number multiplied by another number should give you the answer multiplicative identity, that is 1. So what is the possibility? A by B should be multiplied by B by A, so that we will get answer 1. So the multiplicative inverse of any rational number is its reciprocal itself. See here, 5 into 1 by 5 gives you 1, or 1 by 5 into 5 gives you answer 1. This is multiplicative inverse.